know about this. We have three different pictures here. So this is a picture of a healthy bone. We have a lot of bone here, beautiful. But if you got osteoporosis or severe osteoporosis, you lost bones from your body. Then you have a hole in your bones. And in fact, we cannot see by our eyes. First, we have to go to the hospital and they use the machine, to measure that about healthy of our bone. If the value, this value, T score is less than or equal to minus 2.5 standard deviation, then this case is osteoporosis. And if it is between minus 1 and minus 2.5, we can have osteopenia. And if it is greater than minus 1, we normal bone. And this criteria can use to classify our bone. And we also have this tool for our foot. So we have the Excel files from Nakhon Hospital. We have something 300. 23 is unknown. We don't know about the results. 18 is normal woman, and 266 is osteopenia or osteoporosis. And in this data set, we can classify into three types. It is biography, anthropometric, and vital sign data. This is normal that when we go to the hospital, they ask us how we weigh, something like this. And we also have the biochemical data. We have the behavior and the treatment data. You drink the coffee, milk, take hormone, or something. And this is the data set that we have in our electric files. And we study this data set. And 2 years ago, we go to Pathom and we submit the paper about this work. And we don't success at that time. We submit many times after that until we can publish. The first, in fact, this is the first work that we did. We use the machine learning to classify the postmenopausal osteoporosis type woman. We use many methods from machine learning. We use support vector machine. We have decision tree. We have KNN. We have ANN. I cannot remember how many we use, but we use many methods from this work. And we use it later for this research. From this paper, we have the feature from different methods to choose the feature. As I told you that data for biographic data, biochemical and behavioral, many of this, and we don't use all to create the model. We use only some data to create some feature to create our model. And we need the criteria to choose which feature or which variable is the best or not the best. That we have the criteria and the method to use the feature. So this is 9 methods that we use to select the feature, and this is the feature that we use. But I have more, but I show you only some of them. And this is the first work, and the second work is something like decision tree modeling of osteoporosis, menopausal type women. Yeah. And we create the decision tree. We use the decision tree to find the model, the rule to classify that you are in the case to be osteoporosis or not. So this is the three rules that we got for this work. Maybe you can learn more from this paper. So if age greater than 58 for postmenopausal woman in Thai woman. So this is abnormal. Abnormal means you can be osteoporosis or osteopenia. So I can be 58 in a few years. So and if the age less than or equal 58 and the weight greater than 57.8, so this is normal. And the third rule is if the weight less than 57.8, so obesity is more girl, so in this case it is abnormal. So this is the three rules that we create in this paper. And in this work, we are thinking because here, this work is something like machine learning. We use the machine learning method, and I am mathematician. Two of my students also mathematics students, and I like to create mathematics model. I want to know the equation. I like equation. I want to know the variable. I don't like the black box. I don't like something that I cannot see inside. You know, machine learning something give you output, but they don't tell anything inside what they use or what is the equation they have in that formula. So in fact here in this work we also use the support vector machine, and we don't know the equation, and it is my question that why we cannot see the equation from this model. Therefore I try to create I try to create the equation. So this is the method that I use to create the equation. So we have 379 data. This is not much. You cannot say that it is a big data. But in the medicine, if you have only 3 or 5 cases and you can get some useful information, it is great for your field, because for example you have heart attack, you cannot collect many patients for this disease. So for 300 records, I think it's good for medicine. But I like to have more, but limit for our case. Then we split the data into two sets, and we use the random oral sampling for the training data. This is because in this data set we have, it is normal that the normal people is less than the abnormal patient. You know, when you go to the hospital, so usually the women have some problem that they go to see the doctor. Therefore, we have normal woman less than abnormal woman, and we want to use random oral sampling to balance two class for normal woman and abnormal woman. And then we also have missing data because you know when the people record the data, sometimes they don't get all information we need. Sometimes they forgot. Sometimes the patient don't know the information. Then we need the missing value information. Otherwise, we cannot create the data. And after that, we normalize the data. At the first step for my student, we don't normalize the data. Normalize data means I make the data into -1 to 1, not less than -1, not greater than 1. Because if you use the height, can be 155, but if you use some information like paid meal or not milk, you can have only 1 and -1. Then if we have this very big difference value, then it has some effect to the model. You can try to learn about this later. And then we construct the model by using the support vector machine, and we have 9 models. Why we have the 9 models? Because of different set of features that we take from this publication. And therefore we have 9, and then from 9 models we compare the classification for performance by using casing data set here. And yes, because we need the value in the interval -1 and 1, we have to normalize the data again. And from 9 model, we can say which model is the best. The best mean in 9 model, not for, I don't compare, I don't say other model, but I say something in 9 model, the best one. Okay. And yes, this is the result. We have the 2 class. One's I lost some. One is something like abnormal, and this is normal, this is abnormal, something like this. So sorry, I lost some information because we have 2 classes. Yes, to make imputation, we use means imputation and this is a lot of T, and more imputation for non-numeric data because we have some data which is not the number. And yes, and then we have to normalize the data. And here, this is the idea to construct the support vector machine. So we try to create the hyperplane. So I show you, maybe you see this picture before. Here we have two groups, and I plot in two dimensions, therefore you can see the line. And in fact, we have many features, then it can be hyperplane. We create hyperplane to split or to separate two classes, but this is a very perfect picture because two classes don't mix. But in fact, it is not like this. But in mathematics, say that we have to minimize this function. So I don't go to the detail because I have only 3 minutes here. And we have the equation look like this. We create these equations and we have one parameter for minimization problem and one parameter for the fixed point iteration method. So in mathematics we have to find which is the best value for these two parameters. But for this work, let's say we don't have the rule or any method to select these two parameters. My student just choose a good one in her experience, and she said this is good in my experience, and I choose this one. And here is the feature again. You can see, maybe you know what it is here. And here we have 9 models with different features. For the first model, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 features. And for some model 5, we have only 5. Model 6, we have 4. So in the different model, we have different features. So I told you already that one is, and we can show the equation that I really love it, and you also love it, right? Why not? Yeah. Okay, this is model 1, and the equation looks like this. You see 8 divided by 75. This is because I normalize the 8 of the data. And 75 is the maximum 8 in my data set. Therefore, we divide it by 75. Therefore, it may not applicable for women that's older than 75. For example, if we put 8 here, 80 divided by 75, it's more than 1. Therefore, my model cannot use it. Okay, it is the same idea for the left. And here is the classification performance. We have the sensitivity, specificity, precision, and accuracy. And this is the confusion matrix. This is 2 positive, 2 negative, 4 positive, and 4 negative value. And we compare these 9 model and see which is the best value. But it is also difficult for us to say which one is the best, because sometimes we have let's say something, we have 100 for specificity and precision, but this sensitivity is low, the accuracy is low. Therefore, we have to choose. In our case, we choose the sensitivity to be the first measure, because we try to look to find the woman who has probably she has the osteoporosis. If she is osteoporosis, then she can go to the hospital to make a scan her bone again. This is only the screening tool, not say anything that you are the patient. No? Therefore, we use the sensitivity. So maybe you can choose one for me. Model 1. Maybe you have your idea 2, 3. Is 3 the best? No. 7. In 100 people, you can say predict only 7. Model 4, you have 100. No? 5, 6. I heard 6, 7, 8. Who choose 8? No. 9. 7. Someone choose 7. 65, 100, 168. Good choice. Okay. And how about 6? 6 is not good. But we have 82 for sensitivity. Difficult, no? Difficult. Okay, I don't say anything about 9 models. Okay, then the last slide. I also compare to this paper because it is our work, and in this work we also we also use the support vector machine, and in the blue color here, this is the performance from this paper, and in this paper we don't know the equation, and in the comparisons it is also difficult to say, but in my case I may say that model 6 is better than this verb because we here its specificity is 0 for this paper, and we have also a high value of sensitivity here. Yeah, but I don't know which one is the best, but if I have to choose, I choose 6. Maybe here. Yeah, that's all for my present today. Thank you.